Welcome to Hello Experts. Today we are delving into the fascinating world of railway signaling systems. Join us as we explore the vital technology that controls train movement, ensuring safe and efficient travel on the tracks. From historic beginnings to modern innovations, get ready for an informative journey through this critical aspect of rail transportation. Railway signaling, also known as railroad signaling in the US, is a crucial system employed to control the movement of trains on rail networks. Trains operating on fixed rails face unique risk of collision due to their massive weight and inertia, making abrupt stops challenging when encountering obstacles. Rail signaling, also known as railroad signaling in the US, is a crucial system employed to control the movement of trains on rail networks. Trains operating on fixed rails face unique risk of collision due to their massive weight and inertia, making abrupt stops challenging when encountering obstacles. In response to Armagh rail disaster in 1889, the UK's Regulation of Railways Act imposed requirements for safety measures like interlocked block signaling. Various methods of train control involve passing movement authority from rail network section controllers, for example, signalmen or station masters, to the train crew. The rules and equipment used for this process define the method of working or operation. Some methods do not require physical signals, and specific systems cater to signal track railways. In the earliest days, trains were hauled by horses or mules, accompanied by a flagman on horseback. Hand and arm signals were used to direct train drivers, while later flags and lanterns were employed during foggy or low visibility conditions. The roots of wayside signaling can be tracked back to 1832, utilizing elevated flags or balls visible from afar. Railway signaling is a system used to control the movement of railway traffic, ensuring that trains are kept safely apart and allowing for large stopping distance. Here are some key elements of railway signaling. The number one is trackside signals. The traditional approach to signaling is to use trackside signals to control the safe movement of trains. These signals are like traffic lights and use different colors to indicate when a train should stop, proceed with caution, or continue at normal speed. The second is interlocking. Interlocking is a system that ensures that the signals and switches are coordinated so that a train can only move onto a section of track if it is safe to do so. This system uses mechanical or electronic devices to prevent conflicting movements. The third is cab signaling. Cab signaling systems rely on various technologies such as tachometers, accelerometers, ultra-wideband units, inertia measurement units, track circuits, transponders, and communication-based train control systems. These systems provide information to the train driver about the speed and position of the train, allowing them to operate the train safely. The next key element is train control. Train control systems use computers to monitor and control the movement of trains. These systems can automatically adjust the speed of trains to maintain safe distances between them, and they can also provide information to train drivers about the speed and position of other trains on the network. The next key element is European Train Control System. The ETCS is a modern train control system that uses digital technology to improve the safety and efficiency of railway operations. It allows trains to run closer together and travel at their best speeds while maintaining safe braking distances. In modern trains like maglev trains differ significantly from the traditional railway signaling system used in old wheel-on-rail systems. Here are the key differences. Maglev signaling system. The number one is automatic centralized control. Maglev trains are computer controlled, and an automatic centralized control unit manages the movement of the trains. This eliminates the need for traditional trackside signals and human operators. The next key difference is in-cab signaling. Some maglev systems feature an in-cab signaling system that provides information to the train driver about the speed and position of the train. This allows the driver to operate the train safely and efficiently. Minimal use of wheel train technology. Maglev systems make minimal use of the wheel train technology and are not compatible with conventional rail tracks. They rely on magnetic levitation and propulsion using electromagnets, eliminating the need for traditional track-based signaling system. Railway signaling systems bring numerous benefits, including enhanced safety through advanced technology, reducing accidents and errors. Efficiency improves with upgraded systems, managing train movements and minimizing delays. Reliability increases, ensuring more trains run smoothly and passengers experience fewer disruptions. Capacity expands with future signaling technologies, allowing closer train spacing while maintaining safety. Additionally, digital systems offer better Wi-Fi, internet, and phone coverage, elevating the overall customer experience. That's all for today. I hope you have enjoyed the video. Thanks for watching.